Hi everybody, welcome back to the Feynman technique. Today we're going to be doing something a little bit different. We're going to be doing evaluating an indefinite integral. Normally on this channel I do definite integrals. This will be one of the few exceptions. This I got off of an old video off the channel Black Pen Red Pen, and I believe this is a JEE advanced integral. It's off that test from 1 year or another, I forget. So this is supposedly an extremely difficult problem. I found a way to make it easier though. I'm not actually sure how Black Pen Red Pen solved this, but what we're going to be doing today, we're going to solve this with integration by parts. But not the standard method of integration by parts. The standard method uses a reversal of the product rule. We're going to be developing an integration by parts method today that involves a reversal of the quotient rule. So let's go ahead and get started. So we know this. We know that if we have f, some function f and some function g, and if we have f over g, and then take its derivative, we get g f prime minus f g prime over g squared. You all know that. Okay. Well, let's reverse it. Let's reverse it the same way that it would have been taught in Calculus 1 or maybe Calculus 2, the reversal of the product rule. Let's just do that, but with the quotient rule. All right, so let's integrate both sides. So this side is easy. We already have a derivative, so this just becomes f over g. And now this is going to become the integral of f prime over g minus the integral of f times g prime over g squared. All right. And now we're just going to switch this with this, and we have our integration by parts derived using a reversal of the quotient rule. So this means that the integral, if we have it in this form, f g prime over g squared, that will be equal to the integral of f prime over g minus f over g. That makes sense, right? Okay, so now we just need to figure out what f and g are in here. Okay, well, what's the first clue? Well, let's solve for g first, because we know that whatever our g is, it's squared and in the denominator. So our g has to be this x sine x plus cosine x. So we'll just write that. G is equal to x sine x plus cosine x. So now we have g. Let's just go ahead and find g prime, because we're going to need it. That means g prime is equal to, let's see, first times the derivative of the second is x cosine x plus the second, which is sine x, derivative of the first is 1, so that's going to be plus sine x, and then minus sine x. So I didn't even need to write that. So there's our g prime, which is nice. Okay, so given that, now we can solve for f, because we know that f times g prime has got to be the top of our integrand here. That has to equal x squared. Well, we know g prime, so let's divide both sides by g prime. So that becomes our g prime, or I'm sorry, our f. F is x over cosine of x. Let me make sure I did that right. Yeah, g is definitely that. G prime, first times the derivative of the second plus the second derivative of the first minus this. Yeah. All right, so f has to equal or I should say that f times g prime has to equal x squared, so, and g prime is x cosine x, so yeah, that's right. All right, now let's find f prime. F prime, all right, well, we have cosine x minus or plus x sine x over cosine squared x. Let me make sure I did that right. All right. Low d high, that's right there. And then minus x times the derivative of cosine x, which is minus sine x. So that's plus x sine x. All right, that's correct. All right, so now we have all the pieces for our integration by parts. So let's just set this equal to the integral of f prime over g. I'm sorry, yeah, the integral of f prime over g minus f over g. So this is going to be equal to the indefinite integral of our f prime, which is cosine x plus x sine x over cosine squared x. See, that was our f prime, and we're looking for f prime over g. So now we divide this by g, which is x sine x plus cosine x. That's convenient. So this whole thing becomes the integral, the indefinite integral of 1 over cosine squared x, which is the same as the integral of secant squared x, which is nothing but tangent x. So this whole thing becomes tangent x. Okay, and then we have minus f over g. So we're pretty much done. Minus f over g. What's our f? X cosine x. That's our f. Oh, I'm sorry. F is x over cosine x. X over cosine x. And then that's f divided by g, and our g is x sine x plus cosine x. So x sine x plus cosine x. And let me move this x right here, and we're done, right? That's it. That's the answer. No, it isn't. Don't forget this. This is an indefinite integral, so we have to have the constant of integration. But anyway, I'm not even sure if this is the form that he wrote it in, but that is 100% true. That is the answer to that indefinite integral. And that really wasn't that hard, was it? I mean, if you know when to apply this, it can actually be a really, really powerful tool. And the way you recognize how to, or when you might want to try it is if you have an integrand where it's something over something else, and in the bottom we have something squared. So if you see that form of an integral, maybe consider trying this new method for integration by parts. But anyway, there you go. Hope you enjoyed that.